Welcome to Swell Academy, everybody, brought to you by Mr. Math. Today we're going to be talking about one-step equations. First thing I want to look at with you guys is kind of just give you an idea of what an equation is when solving for an unknown or variables such as x. Again, you can use any letter you want to replace for an unknown, something we're solving for, A through Z. Usually you see X marks a spot, that's what we're looking for. So let's begin our treasure hunt. Let's just take a look at basically what this set is saying is X plus 3 negatives will give us positive 2. So what is X? Well, what I like to do is take a look at maybe some counters and basically turn this X into an unknown, a question. What is it that we're missing here? Plus 3 negatives is equal to 2 positives. Now, in order to find an unknown, what you're going to hear me talk about is doing the opposite, doing the inverse. So what sort of opposite to a negative would give us a positive? Well, opposite would basically be adding. So now if I want to cancel out 3 negatives, I have to use 3 positives. But remember, I ended up with 2 positives once I took away 3 negatives. So what would I have needed to, well, I would need 2 additional positive markers, because if I were to cancel out these 3 positive negatives, then that's additional 2 positives I'm left with at the end are what allow me to equal this to the 2 positives here. Now, when we're looking at that question, x minus 3 is equal to positive 2, and we're saying to ourselves, okay, what do I need so that when I cancel out positives with negatives, end up with a positive 2? Well, what we did was we did the opposite, and we add, and what we're going to do here to find out what it is that we're looking for, we're going to get this. You're going to hear this a lot in Algebra 2. Get x by itself. You're isolating this, and that's what this is what x was here, right? Was these 2 basically this 5 positives here. So in order to get x by itself, to find out what it is that we need here, we need to move things to what I like to say is the other side of the equal sign. We look at this kind of like half court of a basketball in a basketball gym. Like, we need to move to the other side of the court here, and to do that we have to add 3 to both sides. And if we do that, this is the canceling out of the 3. This is what happened here. This negative 3 plus 3 is this canceling out here, and then this plus 2 plus 3, which left us with 5, which is what we have inside this box here. This is what we needed, these 5 positives, so that when we combined it with 3 negatives, we're left with 2 positives. Let's take a look at another question, kind of somewhat with the counters, and just give us a little bit more of an idea of again what we're doing. Okay, so again we have those 5 positives, and we want it to be equal to 2 positives. So what we were doing was opposites, right? We were subtracting 5 from both sides, and we're ending up with x equals negative 3. So what does that mean? Looking back at counters, remember last question we used the counters, then found this. So now we're finding this. Well, we need 3 negatives. Okay, so let me put the 3 negatives, what x is here, right? We found the answer first. Now we're going to look kind of counters second. We'll look at what we have with the counter second. With our 5 positives, and here you go, that canceling happens again, the inverted opposites, and there you are left with your 2 positives. That's where the 2 positives are come into play here. And that's generally the idea with your one-step equations, adding and subtracting, is this idea of using opposites, canceling out. Now there are some special different style type questions which I like to bring up, one of which is where you have a negative in the answer. On the other side of the equation you have an answer of that is negative. You have your basically equations set equal to a negative number. Now we know we want to do opposites, your inverse, add 7 to both sides, but I like to bring this up because some students, they have a tough time distinguishing, well, what does this mean? Is this a 9? Is this a 5? Is it positive, negative? Well, we looked at our counters, and remember, whatever we had more of, like in this case, we had 5 positives, whatever we had more of was the sign of our answer. So here we have 7 positives and 2 negatives. We have more positives. So the idea is, because we have more positives, our answer is going to be positive. Now, how many more positives do we have more than negatives? Well, the difference here between 7 and 2 is 5. So we must have 5 more positives. And I really like to bring that up, just the idea of, okay, we don't want to draw these counters each time. So what are we going to be thinking? How are we going to think about this question? Well, we're going to look at 2 and 7. We're going to recognize there's a difference of 5, and we're going to recognize that there's more positives, and that should help you going forward. Another question I like is, and you might see, is where you're subtracting a negative number. And this idea here is basically you're taking the opposite of 3 negatives. So taking the opposite of 3 negatives is basically 3 positives. So when you see a negative and negative, it is, if I like to say, you did not, I don't know if you'll be able to see that, you did not add, which means you added. So if we did not add, we added here. So, and then to solve for this, we'll use opposite. Now I like this too, because here you're not looking at different signs. Here you're looking at the same sign. So basically you're adding these numbers, you're adding a total amount of negatives. We have 1 negative here with the 3 negatives here, and that's actually going to give us a total of 4 negatives. So if you have the same sign, you're basically totaling up that amount of counters, and you'll get your x equals to -4 here. And it's important too to check your work. So basically, you know, if we want to check our work here, and we did -4 minus a -3, and we did -4 plus 3. Here we have numbers with different signs, and we're going to do -4 plus 3. You're going to get your -1, which is exactly what we wanted in the beginning here. A couple more examples. Here's one where you have x minus 5 is equal to 10, in which you are going to just simply add 5 to both sides, and you have, again, same sign. So I wanted to show you, we looked at negatives with the same sign. Here you have positives with the same sign. You're just simply adding these together, and you're getting x is equal to 15. You may see a question where they give you a negative in the answer here. So here we had x minus 5 is equal to positive 10. They may give you a positive 5, and you're adding 5. And even though you're adding, remember, you have, what do you have more of, negatives or positives? You have more negatives. So that's what we're going to use. And how many more negatives do we have than positives? We have 5 more negatives. So you may add to a negative number, and your result may remain negative. And again, if you're not sure, check. If I spent $5 today and spent another 5, and subtracting 5 from my wallet in consecutive days, I spent a total of -$10. Math may throw you a question in which all of a sudden your unknown, your variable is a negative. Well, what does that mean for me when solving this? Well, I recommend that you guys, students, just kind of, again, we're isolating the x. You may even consider this a 2-step problem here, but sometimes it's presented as a one step. Subtracting 3 both sides, x minus 3 is equal to 7. We want to know what x is, not what negative x is. So how do we get x by itself here? Well, technically you're supposed to divide by -1, and we'll kind of explain that more when we do one-step division multiplication, but really all you need to do is change the signs. That's what we'll do here is everything changes. So this negative becomes a positive, and this positive 7 now becomes a negative. So really you're just switching the signs. Again, just a little bonus here, could be considered two-step, but if you're presented with this as a one-step, that's what you'll use. This is going to require a lot of practice. I like to tell students, you cannot succeed without failure. And the more you fail, the more you're going to succeed. The more you fail. So practice these, get them wrong, look at your mistakes, check your work, see what ends up happening, and then start to use bigger numbers, start to use decimals, start to use fractions, and we'll actually get a video where we look at one step with fractions and decimals, but right now we just want to get an idea of plus and minuses. Thanks for stopping by. Remember, hard work, or math is easy with hard work.